These changes occur when a pump starts or stops, or when a valve is opened or closed in a distant length of the piping, or if power is lost. The loss of power on a pump can create a column separation as the fluid in the pipe continues to flow. The fluid continues to flow through the piping until the column senses the stopped pump. Without the pump, the fluid flow now reverses direction and picks up speed until the vapor created by the column separation almost instantly collapses. The check valve closes after the vapor is dissipated due to the increased reverse flow pressure from the long length of piping. The fluid pressure created now builds in the long length of piping due to both the vapor collapse and the check valve closing. The pressure momentum of the fluid flow can result in a pipe rupture at a weakened point in the system, such as an elbow. The closing of the valve also can create pressure transients in the piping. As the water flows normally, a gate valve is shut a long distance away from the pump. The pump continues to run against the closed valve. The sudden closure of the valve, together with the momentum of the fluid column, can overstress the piping and can result in material failure as the pump continues to run. To prevent stress piping, the Young Engineering line of surge tanks has a gas-charged bladder installed in the tank. The tank's bladder is initially filled with the gas precharge. Fluid enters the tank through a screen and compresses the gas-filled bladder. This shock absorber effect protects the piping and its components. The initial startup of the pump supplies fluid to the destination, also filling 1/3 of the tank with fluid. When high pressures occur, such as a valve closing with the pump running, the piping pressure is dampened by further compressing the gas in the bladder. With the valve closed and the pump still running, fluid now reverses flow out of the tank from the pressure in the gas-filled bladder, pushing against the pump pressure. This action now oscillates, moving the equalized point in the piping back and forth until the fluid energy has returned to a static state.